On to section 8.4, where we're going to look at matrix operations, determine if we have equivalent matrices, addition, we're going to add matrices, we're going to do scalar multiplication of matrices, and actual matrix multiplication. There's a difference between the two. So to start us off, let's again recall your dimensions. It's always rows by columns. And what we're going to start to see is the entries in your matrix are going to have these little subscript numbers. Now, this doesn't mean 11 and 12, 21, 22. There's a reason for what those stand for. So, for example, 21. Again, that's not 21. That really means this is entry row 2, column 1. That's what that 2-1 really means. Now, if you're dealing with a matrix that's really big and has double-digit rows and columns, then they'll separate it with a comma. So you would see A sub maybe 12, comma, a 1. Okay? Equivalent matrices must have the same dimensions and all corresponding entries must be exactly the same. So you'll see an equal sign between your two matrices. So again, same dimensions, 2 rows, 3 columns, 2 rows, 3 columns. If this is equal, then your corresponding entries, row 1, column 1, x, has to be equal to row 1, column 1 in the second matrix. So x is going to equal 4. Now, I'm just keeping it simple. What you'll see in the homework is they might have something like 3x minus 7 is equal to 4x plus 9. You set those two expressions equal to each other, solve for x. Here, y is in row 2, column 2. Row 2, column 2 is negative 8, so that's my y. Row 2, column 3 is z. Row 2, column 3 is a 2, so that's what z is equal to. All right, adding and subtracting of matrices. Again, the dimensions must be the same, and you will add or subtract the corresponding entries. So if I wanted to go A plus B, you will have a 2 by 3 plus a 2 by 3. Your answer is going to be 2 by 3, and you just add corresponding entries. 2 plus 8, negative 4 plus 3. 7 plus 1, negative 6 plus 0, 1 plus negative 2, 5 plus negative 9. Crunch the numbers, there's your answer. Now be careful with the subtraction or they start moving matrices around. So we're going now B minus A. So my first entry is 8 minus 2. 3 minus a negative 4, 1 minus 7, 0 minus negative 6, negative 2 minus 1, negative 9 minus 5. Crunch the numbers. There's my difference between matrix B and matrix A. 6, 7, negative 6, 6, negative 3, negative 14. Can I do these in the calculator? Absolutely. But be careful, be mindful. If your matrices are pretty big, it's going to take time to enter all those matrices. It probably might be faster just to do them by hand. All right, next we have to have a zero matrix. A zero matrix is where every entry is 0. Now the reason for a zero matrix is because if you're going to have addition, you have to have the identitive identity, which means I can take this matrix A and I should be able to add it to the zero matrix and I don't change its identity. It stays the same. So that's the only purpose for the zero matrix. Scalar multiplication, this is the distributive property with a matrix. Oh, I got 2 periods there. All right, find 3A. So what that means, if we take our A, which was 2, negative 4, 7, negative 6, 1, 5, and we have the 3 multiplied to the front, we're just going to distribute it to every entry on the inside. So everything on the inside gets tripled. 3 times 2 is 6. 3 times negative 4 is negative 12. 3 times 7 is 21. 3 times negative 6 is negative 18. 3 times 1, 3. 3 times 5 is 15. So far, pretty straightforward.